Hello everyone, in this video we are going to work on logarithms and their properties. As you already know, if y is equal to a to the power x, then it will be equivalent to say that x is equal to log of y to the base a. As you see, base in logarithm and in the index both are the same a, so a to the power of x will be y. It is exponential form and it is the logarithm form. Now let's see some properties of logarithms. Properties of logarithms. First thing that you need to know is that when base is not mentioned, for example, when you write just log of a, it's the same as log of a to the base 10. So when you don't have base, it means that base is already 10. Now, property 1, log of a to the base a is equal to a to the power of what number becomes a? So definitely 1. Just here, I would like you to know that y should be greater than 0, a must be greater than 0, and a should be a number other than 1. So y is greater than 0, a is also greater than 0, but a shouldn't be 1. Now, second property is log of 1 to the base a. We already learned in O level a to the power of what number becomes 1? Definitely 0. A to the power of 0 becomes 1. Property 3, log of a to the power of n to the base a is equal to, you clearly see that a to the power of n becomes a to the power of n. So here on the right hand side we will have n. The fourth one, a to the power of log of x to the base a will be, see here you have an exponential expression in which the power is a logarithm, and see these base and the base of logarithms are the same, so what remains is x. Now let's see some examples. Example 1, convert 5 to the power of 3 is equal to 125 to logarithmic 4. Now 5 to the power of 3 is equal to 125. Now I wanna change it to logarithm form, so I write logarithm of, what is the base here? 5. Logarithm of 125 to the base 5, 5 to the power of 3 becomes 125. So logarithmic form will be log of 125 to the base 5 is equal to 3. Now let's see another example. Example 2, convert log of x to the base 3 is equal to 2.5 to exponential form. Exponential 4. Now, so I write log of x to the base 3 is equal to 2.5, so 3 to the power of 2.5 will be equal to x. Now let's see some more examples here. Now here find the value of a log of 16 to the base 2, and part b log of 1 over 9 to the base 3. So for the first part, I write again the question is equal to, now Instead of 16, I replace it with the equivalent exponential form, which is 2 to the power of 4 to the base 2 is equal to, so here 2 to the power of 4 becomes 2 to the power of 4 here, or as you see in one of the properties, power comes actually out, so it will become 4. Now b, log of 1 over 9 to the base 3 is equal to log of, instead of 1 over 9, 9 will be 3 squared, transferring to numerator, it will be 3 to the power of negative 2 is equal to 3, so it will be, you can bring the power out, it will be log of 3 to the base 3 is equal to log of 3 to the base 3 is 1, so overall you will have at the end negative 2 as the answer. Now another example, simplify log of third root of x over x to the base x is equal to x, the third root of x will be x to the power of 1 over 3, and it is x to the power of 1, so base is x, so it will be x to the power of 1 over 3 minus 1, so is equal to log of x to the power of 1 over 3 minus 1, it would be x to the power of minus 2 over 3 to the power of x. I bring power out, it would be minus 2 over 3 log of x to the base x, which is equal to log of x to the base x will be 1, so at the end you will have minus 2 over 3. Now in this part I would like you to learn some more properties and laws on logarithms. So the laws of logarithms. The first law, log of xy to the base a will be converted to log of x to the base a plus log of y to the base a. Now let's see the proof. As I initially told you, when you have exponential form, logarithm is inverse of exponential form. As you see here, they have somehow exponential properties. We know that when you multiply two indices, powers are added. Do you see? It is multiplication and addition. So let's see now why. Let log of x to the base a be, for example, here I put it c. So it would be x is equal to a to the power of c. And let log of y to the base a, for example, d. So y will be a to the power of d. Now I replace them. Log of xy to the base a is equal to log of, instead of x, I can put a to the power of c, and instead of y, I put a to the power of d to the base a. Now it will be log of, in multiplication of indices, powers are added, it will be a to the power of c plus d to the base a. I bring the power outside the logarithm, it would be log of a to the base a. Log of a to the base a here is 1, so it will be c plus d, which is equal to, what was c? Log of x to the base a plus d. What is d? Log of y to the base a. So multiplication, logarithm of multiplication is equal to addition of logarithms. Now, the second law of logarithms. Log of x over y to the base a will be equal to, if you remember in O level, when you wanted to divide indices, powers are subtracted. Here it's also converted to subtraction of logarithms. It will be log of x to the base a minus log of y to the base a. So I write as the proof, let log of x to the base a be, for example, c. So x is equal to a to the power of c, and log of y to the base a be d. So y will be a to the power of d. Now log of x over y to the base a will be equal to log of, now instead of x I put a to the power of c over a to the power of d to the base a. It would be log of, powers are subtracted here, it will be a to the power of c minus d to the base a is equal to power. To bring it outside the logarithm, it will be log of a to the base a. Log of a to the base a is 1, so what remains is c minus d, which is equal to, what was c? Replace them back. C is log of x to the base a minus d, what was d? Is here log of y to the base a. The second property was for division of logarithms. So the third is power law. Log of x to the power of m to the base a is equal to m log of x to the power of a. So for any base, you can bring the power of x outside the logarithm. Now let's see the proof here. My dear A-level students, in A-level, nobody asks you to prove these logarithm properties and laws. I just give you for you to have a deep understanding of logarithms and their properties. Now, log of x to the power of m is equal to log of, I write the base. Instead of x to the power of m, I write a log of x to the base a to the power of m. It will be a. Log a to the power of log of x to the base a will be a. So it will be equal to log of, I write the base here, a to the power of, you can write in this form, m log of x to the base a, which is equal to m log of x to the base a. Now, fourth property is log of 1 over x to the base a. Now, instead of x, I write log of x to the power of negative 1 to the base a. It's the power of negative 1, so it will be negative log of x to the base a. It was the fourth properties of logarithms. Now let's see some examples in this regard. Example: simplify the followings. Part A, log of 3 to the base 2 plus log of 5 to the base 2. Second one, log of 8 to the base 3 minus log of 4 to the base 3. And C, 2 log of 2 to the base 5 plus log of 3 to the base 5. Now let's do them one by one. Here it is addition of logarithms, so it will be converted to multiplication. 3 times 5, 15 to the base 2. Here is the subtraction is converted to division. It would be log of 8 over 4 or 2 to the base 3. Here I first put it here in the power. It would be log of 2 to the power of 2 to the base 5 plus log of 3 to the base 5. 2 to the power of 2 is 4, and it is addition is converted to multiplication. It would be 4 times 3, which is log of 12 to the base 5. Now next example, given that log of p to the base 4 is x and log of y to the base q to the base 4 is y. Now express the following expressions in terms of x and y. Express in terms of x and or y. Now, part A, log of p to the power of 5, let me fix it, p to the power of 5 to the base 4 minus log of q squared to the base 4, b log of radical p to the base 4 plus 5 log of third root of q to the base 4, and for c log of, here base is 4, 64 over p. Now is equal to, now as the first one I bring the power, it would be log of p to the base 4 minus 2 log of q to the base 4. So what was log of p to the base 4? X, and here was y. So it would be 5x minus 2y is equal to, here radical p means p to the power of half. It would be p to the power of 1 over 2 to the base 4 plus 5 log of q to the power of 1 over 3 to the base 4 is equal to, I bring the power out, it would be 1 over 2 log of p to the base 4 plus I bring 1 over 3, you have a 5 here, it would be 5 over 3 log of q to the base 4, which is equal to log of p to the base 4 is x, so it is 1 over 2x plus 5 over 3 y. Now for the last one, I write it log of, I first convert division to subtraction. It will be log of 64 to the base 4 minus log of p to the base 4. 64 can be written as 4 to the power of 3, 4, now minus log of p to the base 4. Now here I bring the power outside logarithm, it will be 3 log of 4 to the base 4, log of 4 to the base 4 is 1, so it will be 3 minus, and it is x, so it will be 3 minus x overall. In the next video, we will learn how to solve equations involving logarithms. Thanks for watching this